every day, every hour, this very minute perhaps. Malicious actors are trying to break into your software supply chain. Are you ready for them? September 2021, Travis CI flaw exposed secrets of thousands of open source projects. All credentials to access container registries, private repositories, production environments exposed. October 2021, popular JavaScript package infected with malware. Tens of millions of computers worldwide infected with a password stealer and a miner. November 2021, the log4j vulnerability will haunt the internet for years. Hundreds of millions of devices are likely affected. What's next? In the last few years, we've been having more and more of these supply chain attacks. But what is a supply chain? What's a software supply chain? It's the set of everything needed to deliver software to production. It includes, of course, code dependencies and tools, but also, and most importantly, practices and people. It's not just about tools. So how do we start with this? How do we start securing the software supply chain? Because we can have attacks at different levels. When we work with the source code, then we bring in a lot of different dependencies. We have the build process where we combine the source code and dependencies. We have more dependencies from the build environment. We produce some artifacts. That's the application artifacts we want to deliver to our customers or to deploy ourselves if we are running a software as a service business. And the deployment part. Every step in this software supply chain has multiple security risks and impacts. And of course, we like to talk about tools, because then you apply some tools and you're done with it. But it doesn't work like that with security. We also need the right practices in place in order for using those tools correctly as part of a process to define the security for our software supply chain. And finally, we need people following those practices, right organizational structure that supports and empowers people also to follow the best practices in terms of security. So today I'm going to talk about several tools, but they will not work if we don't have also the practices and the people aspects in place. I'm Thomas Vitale. I work at Systematic in Denmark. I'm a software engineer. I'm a big passionate about anything Java and Cloud Native related. I also wrote a book about it. It's called Cloud Native Spring in Action with Spring Boot and Kubernetes. And overall, I'm a big supporter of open source technologies, contributing as much as I can, both in the Java space and in the Cloud Native ecosystem. So today we'll go through 5 steps and see what we can do as developers to contribute to the overall security of our software supply chain. Because of course, it's not just about what we can do as developers. It's everyone's responsibility. That's always like that with security. But let's focus on what we can do as developers. And we'll start by looking at how we work with our source code. So typically, source code, we work with Git to version control our source code. And Git has a very nice property because it provides an audit trail of every change. So we have this history of all the commits, and we can ask the question, who did this change and when? That's really nice. We like it from a supply chain security point of view. However, can we trust the answer from Git? Let's verify that. So I started a new empty Git repository in here. And the first thing I would do is if I'm working on a new machine, new repository, I have to configure my username and email as Git metadata. So I can go and say git config user.name and pass my name. That's usually something we only do once. And then the email. And since I'm using GitHub, I can use a convenient email address provided by GitHub. So if you plan to send me spam, you have to use another address. This one will not work. And now I can make some changes. This is a demo. And then I can say git add and git commit. We do this every day, right? So there's nothing special there. Update docs and push. And now if I check the Git repository on GitHub, I can get this audit trail. So I can see here there is my commit, committed now by me, since I specified that it was me. And typically we don't work alone on Git repositories. So maybe Mauricio over there would like to contribute to my Git repository, and he would go through the same process. So he would say git config username, Mauricio, and then also configure the email. Once again, we have this email address provided by GitHub. So I can say no reply.github.com. Nice. Let's make some other change and git add, git commit, some update, and push. So it would go through the same process as me. And then if we check the history, wait a second. What did just happen? So your all witness is here. Mauricio was over there. It was me pushing the commit. Yet I can see that it was Mauricio committing to my repository. I even get the nice logo here. I get a link to his GitHub profile. So it really seems authentic. There's something wrong here. And the problem is that it's not even a bug. It's a feature of Git. Git doesn't have any knowledge about authentication. So it doesn't know if who I'm claiming to be is actually true. So if I claim to be Mauricio, Git says, fine, I just use the metadata you're providing in Git. So we need something else. We need somehow to authenticate the users. Otherwise, we cannot really trust the audit trail, because as you can see here, this one is completely false. This is not true, yet it's right over there. I can see, everyone can see that Mauricio committed this. It's only you here in this room right now that you know that it was actually me. So did I hack into Mauricio's account? Not really. Let's see what we can do. Yes. So one way of solving this problem is requiring a signature on the commits. So because Git by itself doesn't know about who we are, or at least it can't validate that, what about applying a cryptographic signature on each commit? So we could use our Git platform like GitHub or GitLab in order to enforce all commits to be signed. So we can make this audit trail trustworthy, because we want to be able to ask the question, who did this change? And we want the result, the answer to the question, to be authentic. So we want to be able to trust that. So we could use some traditional signing with keys, SSH or GPG. We could use a keyless signing approach. So instead of defining some key pairs, we can actually use our own identity on GitHub or Microsoft or Apple, just like when we do single sign-on on other websites. Unfortunately, this part here is not yet supported by platforms like GitHub. So even though you can use something like Git sign to sign in a keyless approach, GitHub doesn't know how to validate the signature. So for now, it's not really an option. But then the important point is that we want to reject any unverified commit. And then we can, every time we commit, we can pass this flag so that we can apply the signature every time we commit. So there's a one-time process to set up the keys. I have already done that, but once that is in place, what we can do is going back to our code. So if I make some other changes now, and once again, git add, git commit. Now there are two different flags in Git. One is uppercase S and one is lowercase s. And this is usually a source of confusion. So if you want to sign a commit, you have to use the uppercase S, even though this lowercase s is short for sign off, but that's actually not for signing cryptographically a commit. And I see this error very often, even on articles or even courses about supply chain security, that they're using the wrong flag. So that's something else. So if you want to apply a signature, you have to use the uppercase S. And then I can say update docs and push. All right, so I use my key to sign the commit. And now GitHub can tell, okay, this is unverified. I don't recognize this key. Definitely it's not the key associated to Mauricio. So I can see that the commit is unverified, and I can now define a rule in GitHub to reject this commit, because I only want to allow verified commits. Once I switch back to my username, then of course it will be verified, as you can see here. And typically what we want is all commits should have this badge if we're using GitHub. We want to be able to trust what we see. All right. Let's go back to the slides, because now there is an important concept in supply chain security related to this, which is provenance. Provenance is a proved and validated history of a software component across its supply chain. So in the case of the source code component, when we work with Git, we now achieve a proved and validated history, because Git by itself provides this history of all commits. If we also enforce signatures, then we can say that it's also proved and validated. So we know if there is a commit from me, that it was actually me committing the changes. All right, let's move on and talk about dependencies, because we start a new project, a new application, we have some source code to write, but typically we also use a lot of different dependencies in our project. And we have great tools in the Java ecosystem to support that. They're really great. And it might seem a bit trivial to talk about dependency management, since it's probably something we use every day, but there are some questions that hide some, maybe some important aspects when we talk about security. A question like, where are we fetching the dependencies from? This might seem a trivial question, especially with my demo application that I'm going to show in a second, because of course I'm fetching from Maven Central. But if you consider a real world scenario, maybe in your company, in your organization, typically you also have some other repositories where you're fetching the dependencies from, maybe some enterprise repository in your organization, or maybe a vendor repository if you're buying some the usage of dependencies from some vendor. So it's not necessarily a trivial question. And then the next one is, which dependencies are we fetching? Because we might see a list in our POM XML file or build Gradle file, but each of those dependencies then have transitive dependencies, which have transitive dependencies, which have transitive dependencies. And I could continue for the rest of the day like that, because there are that many dependencies, and we want to have a way to visualize them all. And finally, if there's any conflict, how do we solve those? Because two transitive dependencies could be the same library, but with two different versions. So are we really sure about which one our build system, Maven or Gradle, will pick? Now I'm going to show just one aspect of this, because there might be some differences between Gradle and Maven. I invite you to try them out and try to answer these questions applied to your real project. But just to show an example, I have here a Gradle application. I have two dependencies from Spring, and I'm fetching the dependencies from Maven Central. Now, perhaps I'm in the context of my organization. I want to also fetch some private dependencies from my organization repository. So I can provide a new one, like that. And because it's positioned like this, Gradle will try to resolve dependencies first from Maven Central. If it can't find them there, it will look into my custom or private repository. That's probably not what I want to do. So I need to position these repositories in the correct way. I know that Gradle follows the sequence, so I need to be careful about that. Furthermore, in order to strengthen even more the security posture, many organizations prefer not having a dependency here directly on Maven Central. But if they have an enterprise repository in-house, they might want to use that as a mirror to Maven Central. So as a developer, I don't have to be concerned with fetching from too many repositories with the risk of using them wrong. I might just have one single repository, and then centrally, the team responsible for the enterprise repository might configure a mirror so that then it fetches from Maven Central or other repositories. But then you have a central place where to check for vulnerabilities, where to enforce certain policies based on your organization policies. And we might do the same in Maven. So if I have the same exact application, let's add a new section for the repositories and add a new repository. ID, yeah, GitHub Copilot really likes completing things that I don't want. So let's say, I don't know, my repo, and then we have the URL. All right, so now I can fetch private dependencies from my repository, but if you notice, there's no Maven Central here. So what happens if we want to say now all dependency resolution goes through my central enterprise repository in my organization? This might look like it's working, but actually it's not, because by default, Maven applies this super POM, where the Maven central repository is configured. So if I want to enforce going through my enterprise repository, I have to remember to disable Maven central, because otherwise they would be enabled. So for all the production releases, I can say enabled false, because by default is enabled. So that's just to show some differences that there might be between the different tools and some way of thinking around resolving dependencies. But that's more about where we fetch dependencies from. So what happens to get a visualization of all the dependencies that we're fetching, all the transitive dependencies, and have a sure answer about how dependency conflicts are resolved. Now, there are different ways. You can add some plugins in Maven and Gradle to output the full resolved list of dependencies, but there are actually standards that we can use to communicate the list of all the dependencies that we use in a project. And that is called SBOM. It's a software bill of materials. It's a nested inventory for software, a list of ingredients that make up software components. So very simply could be just a document where you list all the dependencies in your project, but there are actually some standards that we can use to format these documents so that we can exchange them in a standard way, and also making them machine readable, so we can automate certain things around them. And the two main used ones are CycloneDX and SPDX. I'm going to show some examples with CycloneDX, but actually it's very easy to convert between these two formats, so that's not going to be a problem. Before using them, though, we need to ask ourselves, what can we use them for? Because in a lot of security processes and guidelines, it's like, okay, you have to generate a bill of materials for your application, but I want to know why. If I don't know why, then maybe I'm not that inclined to do things just to get a check on some audit process. I want to know why. I want to know why are they useful. So first of all, again, inventory of all the software components. That's nice. When the Log4j vulnerability was announced back in 2021, one of the problems that some organization had was, are we using Log4j? And it was hard to answer that question. So if we have an inventory, then we can easily tell at least if we are using Log4j and which version we are using. And then once we have an inventory, we can use it to do vulnerability scanning, because then we can go through the list, and for each of them we can check if there is any vulnerability associated with that specific version. Same thing, we can check for licenses, because we want to be sure that we are using components in compliance with the licenses that they came with. We can do that with SBOM as well. We can find outdated component. Since we have all this knowledge, we can automate some checks and see, is there any newer version for a certain library? And finally, we can verify the integrity for each component. Because we are fetching all these libraries, all these binary files, they all have a digest. So it would be nice to use that digest to make sure that it's the same exact artifact or dependencies that goes through the supply chain, so that it's not being tampered with. And we can use SBOM for that as well. At this point, we need to ask the question, when should we build them? Because the supply chain is a series of steps. So at which point do we want to generate a bill of materials? So think about baking cookies. You might go to the supermarket, buy a box of cookies, and you might, let's say that you don't have all the ingredients on the box. Then you break apart the cookie. You can use any sort of chemical process in order to find out which were the original ingredients used to bake the cookies. That's what that's the equivalent of generating an SBOM out of a final artifact. So if you have a jar file or a container image, you can generate a bill of materials in that way. There are very smart scanners that can break apart your artifact, trying to find all the different dependencies. Or perhaps we could do it at source code time. So the example with the cookies, imagine you have, on your table, you lay down all the different ingredients and tools needed to bake cookies. So you could just note down all the things that you see on the table. That would be pretty accurate, but there might be things on the table that will not end up being used, or maybe they're just supporting tools for the cookies, like a spoon, for example. That will not be an ingredient, it's something that you use In a similar way, when you're building a Java project, you have a lot of different test libraries. They don't end up in the final production artifact. But still, it might make sense to keep track of them, because also we want to make sure that the license compliance is okay, that they are not vulnerable, because they're still part of our software supply chain. So we have to consider all the dependencies that we have. So in the end, what we have to decide is how we want to use the SBOM, because we might have multiple ones. We might generate one for a specific purpose, let's say security, another one just for license compliance, another one for doing some extra research. So we could generate an SBOM at different stages. What I'm going to show here today is making the SBOM generation part of your build life cycle. And as a developer, I really like this, because CycloneDX provides a Gradle or a Maven plugin you can add to your project, and then you can just make it part of the normal build life cycle. So every time you build your application, you get an SBOM. And since it's part of the build life cycle, you get full visibility into everything that will end up in the build. You don't have to guess or infer, because it's part of the build, and the build process knows which dependencies are being put inside the final artifact. So it's a pretty accurate result that you can use in different use cases. And for Maven, there's something similar, still CycloneDX official plugin. And you can make it part of your package goal. All right. Let's have a look. So I can just build my project with Gradle build or Maven package. And then I get an SBOM. Let's find it in the build folder. There it is. So you can see it's just a JSON file. It follows the format from CycloneDX version 1.5. It contains all the components in my application. As an example, we have this component. I can see the name, the group, the publisher, Spring JCL. I can see all the hashes that I can use to verify integrity. I have the license information, so I can verify license compliance. And I have this URL. It's a package URL. This is what vulnerability scanners use in order to check if there is any vulnerability. So I have everything that I need, both to keep the inventory of everything that ends up in my application, but also to do something with it afterwards. Because generating SBOM is not enough. What do we do next? We can use it in different ways. I mentioned a few use cases. So the first step could be doing vulnerability scanning. That's a quite important one. So you can use a tool like Trivi, or there are many other open source tools out there as part of your pipeline. So after you build the application, then you can use these scanners. You pass the SBOM file, and then it will tell you if there is any vulnerability in any of your components. But we could go beyond that and consider the whole supply chain security risk management as a whole, and use a tool like Dependency Track. This is just an example. It's an open source tool from OWASP. It's a flagship project from OWASP. It's open source, and it's also written in Java, so I really like it. You can run it as a jar file. You can run it as a container image on Docker, on Kubernetes. And it's all about managing supply chain security risks, because security, any kind of security at the end of the day, is about managing risks. So as part of the pipeline, I can push my SBOM to this service. Let's have a look. I have the dashboard over here. This is how it looks. So at a glance, I can see all the projects, all the vulnerabilities, and how they change the risk over time. And in particular, I have my demo application over there. And from here now, I can see all the details extracted from the bill of materials. So first of all, I get the list of all the components with all the different information associated to it in a nice visual way. I can see the version. Like this one, for example, I get the flag, hey, there's a newer version. Maybe you want to use that. I get the license, and if there's any vulnerability. And then since we have all these transitive dependencies, I also want to see in the a graph of how each dependency is imported in my project. I can do it directly from each dependency, or I can get a graph from here. So I can expand all the dependencies and see everything that is going on in my application. And then, of course, I can check the vulnerabilities. Now, this is an application using an old version of Spring Boot that is using a version of Snake YAML to parse the properties file from a YAML file with a critical severity vulnerability. So I might ship this application, and then I might get called by the security team, all alerted, like, what did you do? There's a critical vulnerability. You ignored it. You just shipped that to the customers, and then the customers call, hey, there's a critical vulnerability. What are you doing? We have a problem here. The fact that there's a vulnerability listed here doesn't mean that our application is vulnerable. First of all, there can be different false positives. Like the whole system right now is subjected to a lot of well, not very useful information that ends up being a CVE, even if it's not really a vulnerability. But then, even if it's actually vulnerability, it doesn't mean that your code is vulnerable to that. So for this specific case, this library has a vulnerability. If you parse a YAML file in a certain way, then it's vulnerable to remote code execution, which is pretty bad. But the problem is, in my code, I'm not using this library at all. And Spring Boot is using it, but is using it in the safe way, so that it's not subjected to the vulnerability. So I really don't want this vulnerability to pop up every time someone analyzes the SBOM, because I know that my code is not vulnerable. So I have to perform some analysis, and I can say, all right, so I'm not affected. So the vulnerability is there in the application, but I'm not affected. Or if I'm affected and I'm working on it, I can choose different options, false positive, in triage, exploitable, and then I can say not using the vulnerable part or something like that. I can suppress the warning, and of course now it will go away from this specific software, but we need a way to communicate this in a standard way. Just like we have an SBOM to communicate the inventory of our applications, we also need a standard way to communicate to all the consumers of our application or library that certain vulnerabilities maybe are false positive or have been managed. And one way of doing that is VEX. So I can export this document here. It's another JSON document. And going back to the slides, VEX is a vulnerability exploitability exchange. So it's a vulnerability document designed to complement a software bill of materials that informs users of a software product about the applicability of one or more vulnerability findings. So it's not enough just to find the vulnerabilities. We have to do something with it. We can automate a few things. Unfortunately, at the end of the day, we still have to do some manual process in order to investigate. So that can create some noise at the beginning if you're just starting implementing vulnerability scanning in your project, but it's really worth going through that. And actually having a process also to communicate the findings, because otherwise you get called by different departments, your colleagues, your customers. So we need a way to deliver that information in a standard way again. And as a developer, since I'm based on all these standards, I don't have to know too much details, but it's important to follow the process. All right. Next, let's talk about the build. We talked about the source code, the dependencies. Now we are putting everything together in a build. And if we work with Java applications, we have 3 different options. I'm using Spring as an example, but it's true for any Java application. We can build a jar out of it and then run it on a Java virtual machine. And we saw that as part of the build, we can also generate the SBOM. We can use GraalVM and generate a native executable. And using GraalVM, besides still generating the SBOM as part of the build process, we can also use a feature from GraalVM itself to generate an SBOM directly, also using the cyclone.dx format. And then we can generate an OCI image if you want to run it on Docker or on Kubernetes. And now, once we build an image, though, we have to consider a lot of new dependencies, because suddenly our application is not depending anymore on the Java dependencies, but then we have also the operating system dependencies. And if, as a developer, I'm building an image, then let's say I'm using a Docker file, then I'm also responsible for what is ending up in the Docker file. Is there any vulnerability associated to the operating system, to the JVM used? I have to consider that. And an important part of security is considering the user experience. Sometimes we focus too much on the security part and we make it really hard for users, in this case developers, to work. So I would like, as a developer, to still have a nice experience and be encouraged to think about security and not seeing as an obstacle to my daily development workflow. So something I like to use to build images is cloud-native build packs, which decouples the concerns because I don't have to write a Docker file. With build packs, I can directly go from source code to container image, no matter the language or framework. It's just one command, And I get the production-ready image, which has been built considering all the security best practices and all the performance best practices. And then it's someone else's job, a platform team, or we can use the open source Buildpacks implementation available to obtain something that is secure enough to go in production. I can install a dedicated CLI like Pack from the Buildpacks project, but in Spring I can do it directly from the Gradle or Maven plugin. So one thing is about polyglot approach, so you can use it also for other application. But an important part, besides having these security best practices implemented out of the box, is that we obtain a reproducible build. And reproducibility is an important property when we want to ensure the integrity of our application artifacts. Because over time, let's say last week, I got this application, I built it, and I obtained a container image. So if today I take the same application, same source code, nothing changed there, will I obtain the same container image? Using a standard approach based on Docker files, that's not true. And Buildpacks provides this out of the box, and I really like it from a security perspective. So let's have a look. I have the plugin from Spring Boot, but the same also Quarkus has the same support from the CLI, and I can say boot build image, and then it generates a container image for me. There are different implementations, of course. For me as a Java developer, I like that I can do it directly as part of my build process with tools I'm familiar with. But if you're working on Kubernetes, there are also Kubernetes-native implementation, so you can define an image object that monitors your source code and automatically builds an image every time there's a change. But I like the approach implemented in the whole Java workflow here. So I get an image. Now, if I check how that image looks like, and here I'm using Podman, great open source tools for working with containers. Let's search for the images is there. Let's search for the demo, and something pops up. So this image apparently is 44 years old, but I've just built it. You saw that, right? So this is very confusing for when people get started with Buildpacks. Now, the point is reproducible builds. In order to ensure reproducibility, we cannot really put the actual creation date inside the image, because otherwise, just because of the difference in the date, then you get a different artifact. So you cannot validate that nothing changed between these two time periods. So for that reason, Buildpacks uses this conventional date. It's January the 1st, 1980. It's an important property, of course, to achieve reproducible builds in terms of supply chain security. But if you like working with Buildpacks, but you really want to see the creation date, you can do that. There is a flag to enable that. But hopefully, your build process has that information already. Like, we don't want to rely on the metadata on the image in order to know that, like the date when the image was created. And we'll see in a second how one way of doing that. All right. But now we get this package, this image. Perfect. Maybe now we want to run it. So I can push it. Let's see. I can say Podman tag. So I tag it so that I can push it to my container registry on GitHub. And then I can say Podman push, or Docker push is the same. So I can push the image, and now you can run it. However, you can't really be sure that eventually the container image you run in production is the same image that I built. It's the same problem we had with commits. We can't really trust this artifact. And how can we solve that? We can solve that with signatures once again. So we can apply the same principles also on these artifacts. We want to secure the artifacts just like we secure the source code. So we can use Cosign. Cosign is a tool within the SigStore project, all focused on supply chain security and signatures in order to sign every step in the build process. So we can use it to sign the binaries. You have a jar file or a native executable with GraalVM. We can use Cosign for that. We can sign OCI image, like I'm going to do in a second. And you can also sign SBOMs, or if you have other documents like the VEX document, it's important to sign them. We want to ensure their validity and integrity. Otherwise, they're not very useful if I can't trust the result. So let's do that. So I can say cosign sign. just like that, and point to the image. Wrong flag, so let's say yes. Let's do that. And now, as you can see, this is the keyless signing approach. So I didn't define any key, but I'm redirected to the browser where I can log in with GitHub, Google, or Microsoft. And I really like that. Now, raise your hand if you like working with keys and managing keys in your daily job as a developer. Okay, I see one hand. That's great. I really don't like working with keys. Like, I always lose them. Well, I don't lose them, but I keep creating new keys for every service. Then I have to make sure that they're not exposed. It's like I much prefer working with a keyless approach. But of course, you have the option. So you can sign it also with using traditional keys. So I can do this. Now I'm authenticated. Perfect. So now my image contains a signature, a cryptographic signature that you can use to verify that the container image is actually built by me. And that's great, but still not enough. Like, you saw me building the image, you saw me signing it, you can verify the signature. However, you don't know what's inside the image. I briefly showed a few parts of the application, but you really don't know where, like all the code that ended up in the image. And you don't have all the details about the specific build process that they used. Like, that is not documented. And that's something that the Salsa framework helps fixing. That's supply chain levels for secured artifacts or something like that. I never remember. But the point of the Salsa framework is ensuring the artifact integrity across any software supply chain. And signatures, of course, are part of it. But we also need to consider how can we know where the container image comes from. So it's the same at the supermarket. If you go and buy some oranges, probably you can see on a label on it that they come from Sicily, in Italy. There's the European Union symbol on it. Maybe you can even see the farm from which those oranges came from. It's the concept of provenance once again. So we want to apply the same concept also for our artifacts, being jar files, container images, or whatever. So, proved and validated history of a software component across the supply chain. We did it for Git, but we need it for all the steps in the supply chain, so including the artifacts. And with Salsa, we can have several layers, so you don't have to implement everything to follow the framework. You can do it in step. And step one is describing. So the artifact has provenance showing how it was built. So it's simple documentation, just describing what you did. Now, maybe you can trust it, or other people can trust it, because you can write whatever in the document, right? But it's a starting point. You have documentation. That's level one. Level two is using a build running on a hosted build platform, like GitHub, like GitLab, or whatever other platform. And that platform then needs to generate and sign the provenance itself. That's great for developers, because again, I don't want to deal with all these details. I want to really code my application and make some, business logic, producing value there. So this is responsibility of someone else. It's the platform team or the team that provides the build platform here. And then we have level three, where with this provenance that is generated by platforms like GitHub not only is signed, but it's also protected against tampering, so non-falsifiable provenance. Now, since I'm using GitHub, I can actually use the official Salsa generator from the Salsa project that they implemented this generator for GitHub. So what I can do, I have a pipeline on GitHub to build my software. And I won't go through the whole chain here, but the important part is that I'm calling into this Salsa GitHub generator. So I don't have to implement myself. I don't have to know how it works internally. I just rely on the fact that that is an official and approved Salsa generator for GitHub. The provenance is signed and is non-falsifiable. I just need to pass information about my artifact. And in this case, is a container image. And finally, of course, I need to validate all this information. This is like with SBOM. Like, just doing this doesn't really help if we don't then take all this metadata and apply some policies around it. So we want to validate all these artifacts metadata. We want to verify the signatures, we want to verify the Salsa provenance, and we want to verify the vulnerability report, because we can also generate this vulnerability report, sign it, and attach it to our container image. So what can we do? We can use some CLIs and make it part of the pipeline. So I have here a couple of examples. Cosine has a verify command that I can use. So let's run it. And let's see where it's running that. All right. So it's checking my signature on the application. So the important part here, the cosine claims were validated, and I can see the information about the image. There's a signature, the digest of my image. So now I know that it was actually me building this image. And then I can also verify the provenance, so that it's not a random image that I built on my laptop that you trust in production, but it's an image built on a trusted build platform with specific information. So in here, it's a long file, but the important part is at the top, verified Salsa provenance. And here you have information about all the build steps executed by the pipeline, the time. So here is where you have the creation timestamp. So since this is attached to your image, you don't need the creation timestamp in the image because you have this signed, trusted metadata next to it in order to infer when it was built. And if you're running on Kubernetes, you can also define policies there. There is a policy engine like Caverno. So you define a policy and you specify, in this case, I want to check all the images coming from my container registry on GitHub. I want to make sure that they have a Salsa provenance and that the Salsa provenance is valid. So we can use all this metadata in order to make better decisions and protect our systems in production. All right, but we saw a few different steps here, mainly from a developer perspective, but that's really not enough. We saw some tools. Remember, practices and people aspects are really important, and it's really everybody's job, security. But we can do our part. Thank you very much, and I have a QR code. Remember to rate the talk from the application, and enjoy the rest of the conference. Thank you. I think we have a minute for questions. So if there's any question, we have a microphone. Yes?
Hi. So actually, we are trying to implement this security scanning Tri-V in our SDLC lifecycle. And as you said very correctly, that there are a lot of false positives. And can you suggest any way or any good practices how to manage them at an enterprise level? Because each team has its own package, and each team, one vulnerability can be a false positive for one and not for other. So how do you really manage it at a CSO level, for example?
Yes. Yeah, that's really a challenge, especially at the enterprise level. So one way to help is having a tool like Dependency Truck that can help visualizing and making it easier for developers to analyze, because sometimes some tools make it really hard for developers to do this. Like if I'm a developer, I want to push a new feature out. I don't want to like go through a lot of different processes and documentation. So making it easier for developers, I think it's a starting point. It's integrated also, like for example, I can create some issues. If I'm using GitHub issues or Jira, then I can have also an automatically generated task if there's any vulnerability found. Unfortunately, I'm not aware of any fully automated way to help all the teams, but my recommendation would be to start small. If it's something new, maybe start with all the critical vulnerabilities, then the high one, and identify also the teams responsible for what. Yes. Yeah, I'll be around if you have further questions. And again, thank you for joining. Bye.